I don't really know when I first became interested in science. I think I was always interested in nature. As a little kid, I enjoyed playing in the garden and looking at insects and invertebrates, and I loved frogs and birds. And so I had this strong interest in trying to understand how things worked in the garden. And I think from there, ultimately an interest in science evolved. So our interest is in a very simple cell biological problem. And the problem is this. Our chromosomes are linear, and therefore they have DNA ends, 2 ends per chromosome. And this is a problem to our cells. Our cells have a very vigilant system by which they monitor our DNA, our chromosomes, for damage. Anytime this system encounters a DNA end, alarms go off in the cell stops dividing, and it will work hard to repair this damage, to take away this DNA end. But there are DNA ends at the ends of our chromosomes, so this system should not get alarmed by our natural chromosome ends. The function of telomeres is to mask the ends of chromosomes in such a way that the alarm systems don't go off in the cell. It turns out that this is a complex element, the telomere, that is composed of both DNA and protein. We have spent 20 years in trying to understand how this element works. We've learned a lot about how the telomere represses all aspects of this vigilant surveillance system. It's interesting that these telomeres get shorter when cells divide, and this happens prominently during tumor development in cancer. In the early stages of cancer, the enzyme that can keep telomeres intact, telomerase, is not yet expressed, and as a consequence, telomeres get shorter with cell divisions, and eventually they become so short that they no longer protect the chromosome end. And at that point, telomere dysfunction, what originates then, creates an enormous mess in the genome. And so we're interested in both aspects of the telomere problem. One is how do they function when they're functional in normal cells, and how is their function lost during tumor development, and what can that teach us about the rearrangements that take place early during cancer formation that drive the malignant transformation of human tumor cells. In general, the public is fascinated by telomeres because of the idea that there is something disappearing from our cells as they divide and get older, and there's always a hope that we might interfere with the aging of our cells. I think the public is very fascinated by telomeres, and if you look on Twitter and you just type telomere into Twitter, you get a whole bunch of tweets every day. So there is a great interest in what's happening at the ends of our chromosomes.